So guys, welcome back after the lunch break. I'm very happy we can start it again with this amazing energy. I mean, isn't it just made for such a performance, this space? Isn't it just perfect for that? Yes? No? Yes? Guys, we are bringing back what we couldn't do before lunch now, and we start with the awards. And then we'll continue with the program normally as was planned. So, guys, are we ready for our first finalist? And this time, I will tell her whole name. It's a lady called Vanya Gupta. She's from India, near Mumbai. And hopefully, is she on the screens? I cannot see that. No, not yet. Oh no, don't tell me, it's happening again. Vanya, where are you actually? Oh, there you are. Yes. Vanya, please introduce us your project, the Cognitive Assessment through MIDI Drum Technology for the Uneducated. The floor is yours.
Thank you. Hello, everybody. Thank you for giving me this opportunity to speak here. My name is Vanya Gupta, and I'm from India. So in 2022, I started helping out at an NGO where I taught underprivileged students basic electronics programming. And during my time over there, I observed that while some students quickly understood and applied the lessons independently, they lacked the resources to truly unlock their full potential. And so this experience highlighted the immense capability that the students possessed, despite the limited support available to them. So to advocate for more educational resources, I realized the need for a way to quantitatively assess their cognitive abilities. So a significant segment of the global population, approximately 800 individuals, have not been exposed to formal education. The lifetime learning experiences of these individuals profoundly shape their cognitive skills. However, the current neuropsychological tools available are predominantly designed for higher educated demographics, presenting a challenge in accurately gauging the cognitive performance of this substantial population. So there are two current methods which address this problem, and I will just briefly explain the issues with them. The first one is Raven's progressive matrices. So this RPM does not capture a full range of cognitive abilities and only relies on abstract reasoning. Also, neuropsychological assessment battery has different procedures required for nearly every patient, making it difficult to administer to a large population. So my proposed solution introduces an 8 drum pad with sensors and a microcontroller unit. So each drum pad consists of an FSR or a pressure sensor and a NeoPixel LED strip. So there are 5 modes in the device to help test cognitive abilities. First one known as memory recall visual, as you can see in the video. There are 4 LEDs that glow in a certain random order, and the user has to memorize and recreate the sequence by pressing on the drum pads accordingly. So this helps to test perceptual reasoning as well as working memory. A similar thing happens using audio is that 4 musical tones will play and the user has to memorize those musical tones and press on the drum pad accordingly. The next one is known as visual quick response. So the user keeps on pressing the drum pad as the LEDs light up, and this helps to test fluid reasoning. Again, a similar thing happens with audio is that the audio tones keep on playing quickly and the user has to just press the drum pads accordingly. Last one known as logical sequencing, which helps to test logical reasoning as the name suggests. So there are LEDs. So the LEDs glow in a certain pattern. The user has to press the drum pad to complete the pattern. Throughout this entire experience, their time responses are captured, how long they're taking to do it, and how many times have they done it correctly and incorrectly. So it uses a MIDI drum system. So MIDI is musical instrumental digital interface. So it uses this for the entire interaction, helping to capture required data, including the time responses. So I'm also using a machine learning model in this known as a KNN algorithm, K nearest neighbors. So this helps to predict cognitive performance based on the data that's already been received. And according to the proximity of different data points that are already there, it helps to analyze in which class does the new data set belong to. So if you can see the results, there's the sequence that gets generated by random, the response from the user, the time responsiveness, and the total number of times it's done correctly and incorrectly. So throughout these 5 testing modes, these values are obtained, and then it helps to calculate the cognitive score. So, talking about the limitations in a short way is that the only issue with this, according to me, would be that only drumming is being explored, and for some students who have naturally gifted musical abilities, this might be biased. Also, I have a couple of future recommendations for myself, which I would like to talk about. Is that first, to help solve the limitation, to explore different other kind of rhythmic engagement as well, and increase the sample size, the diversity. Then, how this device could be used is that for detection of early detection of cognitive impairments such as dementia or learning disabilities. Through long-term studies, it can be identified how their cognitive score deteriorates or changes. And also to basically check the scalability of this project in real world applications where it can be used either in educational settings or health programs where cognitive assessment tools are needed. And the application of this would be to basically help identify gifted students in NGOs, underprivileged students, and then allow the NGOs or their caretakers to give them opportunities based on their strengths, and then help to hone their weaknesses as well. Also to develop educational strategies and optimize the use of educational resources. And that's it. Thank you so much. And thank you for the opportunity.
Well, thank you very much, Vanya. Thank you very much. And yeah, what better you can do with technology than help someone who is underprivileged and bring them back into their track and into the world that is advancing so fast. So thank you very much. And I will ask a second finalist, and that will be you. It's a gentleman called Aditya Kumar Jha. He comes also from India, but he managed to come, get a visa, get a ticket, even though he's not even 16 yet. And he will introduce you his project called HepaEase.
Hello. So imagine having abdominal pain. Oh, can I have the clicker? I don't have the. Yeah. Sorry. Yeah, so let me tell you about myself. Right now, I'm a high school junior, which means I'm in 11th grade right now, and I'm 15 years old. I'll be turning 16 in 10 or 20 days. I come from Mumbai, India. It's the financial capital of India, and it's a really beautiful city. I would recommend all of you to please visit it and give me a ping if you're there. Okay, starting with the presentation. Yeah. Imagine having abdominal pain and weight loss all of a sudden. You go to see a doctor, but you later find out that you have been diagnosed with liver cancer, one of the most lethal cancers in the world. And the only options that you have right now is either opt for medical treatments that cost you thousands of dollars or just count your days left. This is the case of millions of people around the world every year. Hi, my name is Aditya Kumar Jha, and I'm here with HepaEase. So, talking about what I'm trying to develop is, it's a disease. So, talking about this disease, non-alcoholic fatty liver disease. I'm pretty sure most of you have not heard about it, but to give you a very quick overview about what this is, it is something that might be affecting at least one of you in this whole auditorium. And I'm damn sure about it because it affects 25% of the world's population. And that is a crazy statistic. So non-alcoholic fatty liver disease is a very significant silent disorder, mostly because it affects non-alcoholics, which is a large part of the cluster of our population. And secondly, because it's asymptomatic, which is why it's a silent disease, it's a silent disorder. there are no symptoms to it, and you would hardly notice any type of changes in the body when it's basically trying to affect you. And that is the biggest downside of this disease, I would say. So there are no current diagnostic methods to diagnose NAFLD. The only diagnostic techniques that we have are for liver cancer, which are mainly CT scans. We have biopsies, we have blood tests, but the major disadvantages that we have with them are they are expensive, they are inaccurate, they are invasive, which means they take a part of your body. For blood tests, they take your blood out of your body. For a kind of biopsies, they take a part of your specific organ. For liver, they take a tissue out of your liver and then conduct tests on it. So it's quite painful and may cause complications in the future. So enough about the disease now. What am I trying to do here? So when I was in 9th grade, I just thought to myself, like, why do we even treat cancer? Like, wouldn't it be great if we just detect it early? Like, there would be no logic to like go for thousands of dollars of treatment if you just detect it early and just have some subtle changes. So what I did was I developed a two-phase solution. The first was an early detection kit and a risk assessment machine learning model. For the early detection kit, I tried to read some research papers. What is the current work that has been done in this specific field? And I found out that I wanted to use a non-invasive body fluid, which means I didn't want to take any part of the patient's body, of the user's body. I just wanted to use something that is that can be easily used by any patient without any medical assistant, basically just being used at home, right? And it should be inexpensive as well, so that it can be scaled up, used by majority of the population. So I found out that there are two specific chemicals, which are 7-methylxanthine and ceruloplasmin, in everyone's urine. And these two chemicals significantly upregulate in their concentration in patients who are affected with NAFLD. And this is very specific to NAFLD because as the disease progresses further to cirrhosis, fibrosis, and liver cancer, the concentration changes again. So it is very specific to NAFLD, which helps us a lot. Moving further, for the early detection kit, I designed a paper-based strip, which I won't go into the technical details, but if you look at the image that's been shown, it's a very vertical kind of test strip that has a sample pad, that has a conjugate pad, and then it has a display area of the results, where once the patient pours their urine on the sample pad, and there is a set of chemical reactions that takes place in the conjugate pad, then in the results section, there are 3 lines. The 2 test lines basically tell you if you are positive with this NAFLD disease, and the last line validates if the whole test has been done successfully. So this is a really simple product that everyone can use at their homes without any medical assistance or any expert assistance. So that's how it works. And this is the methodology for how I developed it. So it goes through a certain kind of lab procedure. First, we have the pre-treatment of sample pad. Then we go for the nitrocellulose membrane. Then there are preparations of the chemicals that try to bind to the chemicals in the urine. So it's a pretty complicated process, if I have to be honest. But then again, by trying to read and by working in laboratories as I gain experience, I optimized the test strip where it is today. Moving on further, as I told you, the basic methodology, the workflow of the test strip is very simple. You just need to pour your urine, and as the chemical reactions take place, within 15 minutes of pouring the urine, the patient can just get their results on their fingertips. And it's a very easy qualitative analysis where you just need a visual analysis. If you have two test lines visible on the test strip, that means you're positive. And if you have none, you're just safe. And a very big advantage, I would say, for this is that this test is very simple, and the visualizations, as you can see. So the first test is basically invalid because there are no lines. As I said, the control line, the last line should be visible because that validates the test is successful. And the third experiment is a positive experience where both the test lines are visible and the control line as well. And when I tested my product on 50 patient samples in a laboratory in 9th grade in 2022, I got an accuracy of 66.67%, which at this point might seem pretty low, but given that the sample size was really low, I think this can be improved further as I increase the sample size. So it's all a part of the research experience, the research journey that I'm trying to do. And when I compare these results with the existing technology that's been used, like blood tests, and then liver biopsy, and then ultrasound and liver fat score, as you can see that my blue bar is almost competing with these results. So I think as I increase and work upon this further in the upcoming years, I'm surely very sure that this can be used in the diagnostic industry. Now, coming on the machine learning model, I won't talk much about it because it is very simple. You just need to input your medical values into it, and it would give you a quantitative risk between 0 to 100% of how likely you are to develop this disease. Now, concluding. Now, just to be very honest about this is a very simple method for detecting non-alcoholic fatty liver disease. And as I already told you that I don't even know if I have non-alcoholic fatty liver disease, but just by testing myself on this test strip, I was one of the first people to use my own product, and this just gave me a sense of security. So I want to launch this as a periodic assessment kit because most of the people don't go for medical checkups. As earlier at the expo, I was talking to people, and basically no one remember when they had their last liver checkup. So I just wanted to launch this as a really inexpensive and accurate detection kit that everyone can use on a timely basis, 6 months or 12 months or something like that. But that's my main goal with this. And I hope that someday I can actually launch this as a product and make this a significant breakthrough in the diagnostics industry. Thank you so much.
Wow, isn't it incredible what's possible in this age? And the last but not least will be actually a local team, a team of LASAR, of Boris Brovkin and Simon Klinga, and they will present you their project, LASAR.
Thank you, Martin. As a first, we'd like to play a short video. So let's start.
Historic success.
Great success of Czech high school students.
High school students dominate the finals of the prestigious competition.
Conrad Challenge at NASA Center.
They succeeded in the competition of 569 teams.
The competition had 3 categories and you won 2 of them.
Their idea was ingenious.
They had addressed an issue that's a big issue.
This undoubtedly great success, however, is not the end of anything.
Have you thought of using it as a weapon?
Prague, we have a problem.
Prague, we have a problem. Because this satellite has stopped communicating with the Earth.
But we have a solution how to fix that.
The good thing is that the satellite that I'll send you has just a software issue. So what do we do here on Earth when we have a problem? We restart it, and that's exactly what we'll do with the satellite. We'll send up there a high, powerful laser to get there much more energy on the solar cells than the satellite is used to. The system will be in an extraordinary situation and will restart itself. And after that, we can send a reboot signal to repair the mistake in the software, and the satellite can work again. But this is only one thing, because then we, of course, have satellites that have hardware issues and no longer can be repaired. And for those, we actually also can do many things, and we should, because when those collide, they spill like Lego particles. And to be honest, we all know how it hurts when you step on a Lego particle. And now imagine that each of them flies 28,000 kilometers per hour.
The second use case of our innovation tackles exactly this problem. With even more powerful laser, we'll be able to shoot it on the space debris surface to ablate material, particles from it, which will cause action and reaction, and slow the space debris down. It will then start to approach Earth, and when it reaches layers of atmosphere with high density of air, it will burn in it.
For that idea, we were, for example, awarded by the NASA astronaut Megan McArthur, who you can see up there.
She said exactly this: they don't do it because it's easy, but because it is hard.
And that word said, I'd like to ask you, who of you ever wanted to be an astronaut? Just for a moment, do we have some? Cool, a lot of people. And who of you wanted to be a garbage man? Nice. For those of you who raised your hands twice, we probably have a dream job. A space bitch man.
And that might sound like a huge bizarre. And even more bizarre because we are high school students aged between 15 and 20 years old.
But it is not bizarre because we are living here, in Czech Republic, where when you need the help of the experts, they will help you. Where if you come to the largest laser centers in the world that are in Czech Republic, close to Prague, they will cooperate with you.
That's actually how we look like in lab. And on break, we look like this.
So we have the laser, but now we'll of course need the precise tracking system. That's why we started cooperating with Teplice Observatory.
We found out that with their telescope, we are able to track the 1U CubeSat with a precision of 10 meters.
And then those two things combined give us something like this: a precise tracking system or a laser cannon. Do we have some volunteers who'd like to sit on that thing? We have some. I have to tell you that you have a hard competitor. Because this is Lucy, and she really wants to sit on that laser cannon. This is also one of the things why we are doing it. Not only because of the technology, but also because of the motivation. And personally, for us, it will be a great motivation to have our own satellite launched later this year.
It will carry on a lot of tests, which will help us, for example, to measure energy from the laser or the ionization of the space around the satellite.
And then, as an icing on the cake on the satellite that's spinning around the audience, there will be an icing on the cake, a parabole that you can imagine like an umbrella. In its center, there is a nylon, and on the nylon, we'll already try the ablation of the material that could possibly in the future help with cleaning up space debris up there.
But we haven't told you one thing yet, and that is that we don't have our satellite anymore. It's actually integrated into Deployer, which is on its way to the United States, and later this year, it will launch on a rocket.
So later this year, the dream of many of our teammates will actually come true, because we've always dreamed about seeing a real rocket launch on our naked eyes. And this rocket launch will have a little bonus, carrying our satellite that we've worked on together. Thank you.
Thank you.
And if any one of you would like to join the team, we're here, we can talk to you, and if you'd wish, maybe you can be the member of the team tomorrow. Cool. To tady necháme.
Wow, so these were our finalists. I will ask the Regie to prepare our award ceremony setup. And I please ask all the finalists to come here with us. Yes. It's a new venue, so it's a good precaution to have an umbrella. One never knows. I know. So please, why don't you stand here, you two? And Sameh, you can stand over there. Sameh is here representing Vanya, who couldn't be here. Could you stand on that side? And you please stand on that side. No, not on top, just there. If you would stand on that side of the podium. And we will ask our Firefly Fairy to help us choose the winners. And we'll start with the third place. Could you please tell us who won the third place? Anya, please come on. Congratulations, congratulations. And Ferry, please tell us who won the second place.
The drum guys are having fun with this.
As a jury of us speakers.
Oh, we have a second place!
Vanya! Cognitive assessment through MIDI Drum Technology for the uneducated.
Thank you. So Vanya, I hope you can see us. Sama is representing you here. You won the second place. And probably the Firefly can tell us who won the first place. Hello guys, come on.
Laser crew.
And just to disperse any doubts about the, let's say, bias, because the guys are actually from this country, we had a jury which was made out of our speakers who were from the US and also from Czechia, and this was a unanimous result that we got here. So thank you all. You are doing all amazing things. You are inspiring many people to follow in your footsteps, and once again, thank you what you're doing, and keep on doing that. Thank you.